Good morning, everybody. Welcome to Detroit and the nice weather out there. It's a little cold, I guess. I've been living down south for too long. But this will be all about our atomic EFI, the throttle body, as well as the LS controller. And I'll briefly mention one of our newer products, the transmission controller, that'll integrate in with these two items. I'm going to go over the presentation, read the slides. If anybody has any questions, feel free to ask. Just raise your hand throughout while I'm presenting. That's fine. I'll have to repeat your questions so we can hear them on camera. But feel free to raise your hand throughout at any point if you have any questions. All right. Our philosophy for EFI is make it simple enough so that a regular car guy can install it, have as few wires as possible. Eliminate the need for a laptop by using our handheld. Make it self-learning, basically so the O2 sensor can correct for fuel and rewrite in the computer to tables. So that way the more you drive it, the closer it gets and the more accurate it gets. It has to look good enough to show off. We tried really hard on our design to make it look like a carburetor and have as few wires as possible, so it's almost invisible underneath the air cleaner. It has to perform as good as it looks, and we can support up to 620 horsepower. Actually, our test motor that we use is about 650, and runs very well with that. The throttle body design is basically there to replace a carburetor. It's a Holley style 4150 flange. It's, we say, the easiest to install. We have very few connections, a power, a ground, some sort of tack hookup, whether it's off of a stock distributor or one of our distributors going to one of our ignitions to control timing. It's self-learning, again, so the more you drive it, the better it gets. I've looked at a few of them that customers have on their cars, and after 500 or 600 miles, the entire fuel trim table or volumetric efficiency table is correcting and dialed in almost perfectly, so they've got zero fuel correction everywhere. It works very well, and of course it looks cool under the hood. Like I said, it mimics a carburetor, so you can't see much coming out. Really, you see the one main power lead going to the big red power module, and possibly the coolant temp sensor wire coming off of there, and RPM pickup. So it's not many more than a carburetor with an electric choke on there. We try and keep the wiring package small. All the wires are tucked up inside the throttle body. There's a typical installation. Like I said, you've got on the lead going from the throttle body to the power module, you just have your RPM pickup, which would either be the 3-pin or the mag pickup if you're using one of our distributors, and then the coolant temp sensor. On the other side, you've got the battery, the ground, and the ignition wire. Fans are optional if you want to drive fans with it. Fuel pump out, we actually have basically a relay and a fuse inside of the power module. Can run a 15 amp pump easily, 20 amp pump for a short while, but a 15 amp fuel pump without any problems whatsoever. So you don't have to hook up a relay or external fuse or anything like that. It's all done internally. And then the wideband oxygen sensor that has to be installed. So the O2 sensor, you do have to put a bung in the exhaust, as with any feedback fuel injection system. The fuel rail is internal. We tried building in the sensors. We've got the fuel rail, fuel pressure sensor integrated into the rail. The throttle position sensor is integrated into the side of the housing where the ECU is also built in. The map sensor is also encased in there, so we don't have a large external map sensor or TPS where we have to have wires running out to it, and that's how we really kept the wiring down. We use more modern OEM technology on the throttle position sensor. It doesn't have contacts that can wear out or anything like that. So it's a very long-lasting sensor. Basically, it should last a lifetime. It's just a micro and a magnet. So It does support boost and nitrous. We have a nitrous input wire on there. It only supports wet systems, but that means you can do any horsepower level you want because the fuel is not being fed by the throttle body. So on the handheld, you can set up your air fuel at wide open throttle under the nitrous condition. Say you want an 11.8 or a 12.0 air fuel. Your normal wide open without it's a 13.0 or 12.8. And with the nitrous, you want an 11.8, you tell it that. And it will try to correct to that. So your nitrous is adding the fuel, but this will dial it in. If it's off by a half or a quarter of a point, it will dial it in and get right there. If we're controlling timing through that, through the throttle body as well, it has a built-in retard. So it has a step retard that you can tell it how much timing you want it to take out when that nitrous is activated. The boost, we can run up to 15 pounds of boost. The map sensor is actually about a 2.5 bar, but we just say 15 to be safe on that. 930 CFM on the airflow. The handheld is, oh yes, sir, go ahead, sir. Yes, blow through or draw through. The original systems could only do blow through, and then, May, I think, of this last year, we had actually updated the throttle body so it can do blow through or draw through on there. So it eliminates the need for a laptop with this handheld. You set everything up. You set up your cubic inches. See, transient fueling, your air fuel that you want. What else? Fan temperatures to turn on the fans at. I think everything's fairly simple in there. The hardest part is probably the transient fuel, which is still, if you have the handheld in the car with you, takes 10 or 15 minutes to set up typically, doing a couple of transient throttles. It updates with the handheld as well. There's an SD card, so when we have software updates, we'll have a software update actually coming out in about a month or so that'll add some new features. And that's free on our website. You can just go to the website and download it, put the SD card in the handheld, and it'll update the units. The joystick navigates through the menus. You can view live data. There's a gauge screen as well as it's a gauge page and a data page. The data page is more of a large list, and the gauge page can actually be used to view RPM, air fuel, I think coolant temp, TPS, things, fuel pressure. On the gauge page, so if you want to use it as an actual display gauge and attach it to the dashboard or anything like that. A new update coming soon will actually allow you, as soon as you turn the key on, to go straight to the gauge page if you want it. So the customer doesn't have to fumble and switch to the gauge page every time. It'll just be there as soon as they turn the key on. The throttle body plugs directly into the power module with just a single connection. We have all the wires in there. That's the power module. They communicate over a CAN bus. So there's no wiring or very, very little wiring. So the sensors can communicate with the main power module without the need for all the wires. There's just two wires that have to communicate back and forth to send all the sensor data over one line, which on the LS system is actually eliminates the wiring even more on that system. Fuel pump, again, no external relay, no fuse needed or anything like that. It is all included in there. It does have current protection, overcurrent protection, over temperature protection built into the controller for the fuel pump. The fan control wires, they are ground outputs, so they do need relays if you're going to hook them up to fans. They're two individual that you can hook up, and they also will control the IAC to help the draw on the motor when the fans kick on, and sometimes draw the motor down on the alternator. It'll actually kick up the IAC automatically to try and stop that and keep the idle smooth. Timing control. If you want to use timing control, you must use an external ignition box. Provides more precise ignition timing than the distributor weights and springs. You can actually set a curve in there that's basically unlimited. With our distributor, you have to put the weights and springs, and you've got the different degree bushings that allow the timing to move by a certain amount. And the springs bring it in, the total in, at a certain RPM. This allows you to If you got a really big cam motor and you only want a 5-degree spread or something like that between idle and wide open, or 10 degree, you're not limited to that black 18-degree bushing. You can put 5 degrees and say, well, at idle I want 25, and at wide open I want 32. And you can control what RPM that comes in just by typing it into the handheld. The system will actually compensate also for higher coolant temps. If you tune the car, dyno tune the car, or anything like that, and set the timing aggressively and the engine coolant temp is cold, which happens a lot on engine dynos, the customer, when he's out in the field, once that coolant temp does get up above the 200 to 220 range, it will start pulling 1 to 2 degrees of timing to help prevent detonation automatically that you get sometimes during the summer when you get more pinging and detonation during the summer. This tries to help that. It also does it by inlet air temperature, by bringing that down by another 1 or 2 degrees on, if it's above 120 degree inlet air temperature outside, it'll start bringing out 1 or 2 degrees of timing. So the controlling the timing actually helps idle quality and drivability. You've got infinite adjustability for drivability on the idle. The one bad part about a carburetor is RPM drops. Timing actually keeps dropping as well. With fuel injection, you can bring the torque of the motor back up by increasing timing as RPM drops. So if RPM starts dipping a little bit because of a load, putting it in drive or things like that, it can actually bring the idle back up, which can help over not controlling it. Like I said, the distributor will drop in timing, and this will actually bring it back up a little bit. Yes? Well, that's with the ignition timing, you do have to actually run, I'm sorry, the question was a locked out distributor. What if you're running a locked out distributor? You have to actually run a locked out distributor no matter what on the system, because it will control timing. So you do have to have a lockout distributor with a phasable rotor, and you only phase it one of 2 ways. If you use our distributor, it's the small cap style distributor for the motors, and you phase it 15 degrees opposite of rotation. So we've got everything set up so you don't have to sit there and drill a hole and do all the difficult rotor phasing and things like that you do with some other fuel injection systems where you have to look down, and which becomes really difficult sometimes to get the phasing in just right. But the way we set up the crank offset in the computer, it just expects 15 degrees, so as long as you turn the rotor to 15 degrees, it's good to go. So you don't even have to really check it or anything after that. So again, controls timing with power adders with the nitrous, forced induction as well. There is a degree of retard per pound of boost, so if you put in your wide open throttle control on the timing and tell it how much timing you want at wide open, it'll go there, but if you start getting into boost on a forced induction application, it will start pulling however many degrees you enter per pound of boost. So if you want to take out a 1/2 degree or 1 degree per pound of boost, it'll take that right out of there. So there's no need for an external boost retard or anything like that if we're doing the timing control in the atomic throttle body. Any questions on the throttle body system? Yes? Does it have diagnostics? Yes. There is a diagnostic page, and you can come up after and take a look at it on the handheld up here. I think that one's working. Is it? Okay. But yes, it's got sensor diagnostics, O2 sensor, coolant temp sensor, inlet air, TPS sensor. I can't remember. There's 15 or 16 different diagnostic controls on there. This unit does not right now. There is no mill light on the throttle body system. On our next generation one, which will be upgradable, even the current generation, it's just the power module that'll be changed. The throttle body should remain the exact same, but the power module will have an extra wire for a mill light out. It'll be a ground output that you can turn a mill light on with. So, yes, go ahead. Sorry. Fuel pressure requirement. It varies depending on the motor. If you've got a bone stock 625 peak, you're going to want to run about 70 to 75 psi max. If you have a bone stock 305 from the 80s, you're going to want to run 25 psi. My own stock Jeep, it's a stock 76 304, so it's 145 horsepower. I run it right down to about 28 psi, and it runs fine. So it helps on the lower horsepower limit. You can go down quite a ways. I've gone down as low as 20 psi on a 120 horsepower motor. And it works just fine by lowering the fuel pressure down there because it keeps the idle more stable and things like that. The downfall of running really high fuel pressure with small horsepower, low horsepower motors is idle quality can suffer because of fuel injector, but you can turn it down to 20 psi without a problem and actually still idle just fine. Marine applications, we have had quite a few people do marine applications. They use basically the newer fuel injection style manifolds. So they use the exhaust manifolds for fuel injection. They've got the O2 sensor bung and everything in there. The O2 sensor will function fine. The learning doesn't kick in as long as you're using a fuel injected style motor that has a thermostat. Normally they're running about 150 to 170 degree thermostats in that area. As long as it has one of those thermostats, it'll be fine. If you've got no thermostat and you're running 120 degree, 130 degree water temp, it won't ever go into learning, but it will be in closed loop. So the fuel corrections will still happen, but it won't write to the table, so it won't get better over time. But as soon as you break that 158 degree temperature threshold, it will start learning the fuel tables. So, yes?
Once it's programmed with the handheld, you actually plug it in?
No, you can unplug the handheld and put it away, so if you tuck it up under the dash and don't want the customer to have access to it or anything, it can be removed. So, yes? Applications? We've done 6 cylinders. We've had customers do 4 cylinders, V8s, anywhere from the lower horsepower limit, again, probably around the 100, 120 horsepower range, up to 620 horsepower. What's that? Oh, yes, correct. Any square bore intake manifold will work just fine. Or even the adapter flanges we've used on some of the old Quadrajet style intake manifolds, just use a spacer on there, the spacer adapter, and it has worked fine on there. Yes? The injectors are high impedance. Yes. Yeah, they're 80-pound high impedance injectors. So. Okay. Yep. Yes, sir. Pour vacuum, we have a few customers who have gotten it to work really well. We only recommend, so we say 250 degrees of duration and a 108 lobe separation angle. So we like to see about 8 inches of vacuum. Otherwise, the MAP sensor starts having some reversion, and you get a lot of crosstalk between the O2 sensor and MAP sensor, and they fight a lot at idle. If you keep the RPM up just a little bit, like I said, our 650 horsepower motor's got a very healthy, it's actually a little above 250 degrees duration. As long as we keep the idle up around 11 to 1200, it's perfectly fine. A Dominator style or multiple setups, we don't have a Dominator style yet. The market just hasn't been quite large enough yet to go into that. We are talking about a larger horsepower one, and as far as the duals or having multiples on there, we are looking at that as well. We've tested it on the dyno and it's tested very well. We just haven't got anything ready for production as of yet. Yeah, it's just it's got to be volume and everything else. But yeah, the duals, there's an interest that keeps kind of going up and down in the duals, and we keep talking about it, and so we've tested for it, and we know what needs to be done and things like that. So as far as the single O2 sensor instead of duals, we can only control one bank of oxygen or of fuel. It's both. It's going into a common plenum. So even if we had 2, it could be there for diagnostics, but it adds a pretty large cost to the system, and it can't actually control the system with, say, a dual plane manifold. You can't lower the side, one side of the fuel, and hope it corrects that side because it'll lean out both sides with a dual plane manifold or something. Cold start, we've tested all the way down to 0 degrees. I haven't been able to go below that. It's hard to get below 0. Yeah, there's not. Yeah. Down in El Paso, it's very hard to get below that. Yeah. It seems to do very well in 20 below, and through experience, the curve continues down and adds more fuel at negative 20. It may not be 100% perfect there. At 0 degrees, it started very well. If you are doing timing control as far as the distributor goes, you do have to upgrade. There's no way to lock out a stock distributor or phase the rotor. You could weld the distributor and lock out a stock one, but there's no way to, there's no way to phase the rotor on a stock distributor. So you do have to use one of our distributors so you can actually move that rotor to bring it in for timing control. And the phasing part has to do with the way the distributor moves. Anytime you do the key off, it actually will sit there and recompensate for altitude, as well as if you start tipping into the throttle and get to a certain load point on the throttle, it will automatically start recorrecting for atmospheric pressure. So we tested, we tried going from about 1,200 feet. We went up to 10,000 feet without shutting the car off or anything else. Maintained air-fuel ratios and did the same thing. We came back down from that altitude back down to the 1,200 feet. As far as fuel pumps, you can get the master kit that does come with a fuel pump. It's an inline fuel pump, though. If you want an in-tank, the Phantom it's very clean, and we do recommend that system. It works very well. It's hidden inside the tank, and we haven't had any problems with it. We've used it ourselves, as well as had many customers use it. There is return. You can do non-return, and if you do an in-tank system, it's actually you can get away with doing a returnless style. You can do a returnless style on the frame rail, but with heat, it can cavitate without a return. But in the tank, my own personal vehicle, I run a low fuel pressure, but I've been driving it for 2.5 years now. And it's an in-tank pump, and I haven't ever had it cavitate at all. And not vapor lock. Vapor lock's more on the outlet, but on the inlet, the cavitation on the inlet side, absolutely. Yep. No problem. Anybody else? Oh yeah. Good. Right now it's not. In a future update it will be. The throttle body itself, it can definitely handle it. You can actually just change your cubic inches by about 30% right now, and it'll be 85 compatible. It's all airflow based modeling inside the system, so it doesn't know what kind of fuel you have in. So if you just tell it you have bigger cubic inches, it thinks you're putting in more air and will put 30% more fuel in. So if you want to run E85, you just have to change your cubic inches on the handheld. So it's actually very, very easy to do that. So in the future, I'll have an update that will actually allow you to just do that on the handheld and tell it has E85. So. We've actually talked about that as far as the sensor, the composition sensor goes. They're just very expensive. You're looking at $200-300 plus integration and everything else. It can be very expensive for that. That would make it ideal, because then if you've got a 50-50 mix of E85 and gasoline, you've got E40 or E45, and you need to change your air fuel ratio accordingly. But without a composition sensor, you can't really do that. The system does compensate plus or minus 25%. So if you're even in the ballpark, one way or the other, if you're running half and half, you should only be off by about 15% on your fuel trims. 15-12%. So it should compensate no matter what. So as you're running out, if you do a mixture, as you're going between the two, it will be enough to compensate, but you would have to switch between E85 and gasoline on the handheld. If you're running an external pump on the fuel rail, I would definitely recommend a return style system. The pumps run cooler. You don't have as much problem with cavitation or really any chance of cavitation at that point. Move on to the LS system. The system we came out with about a year ago. With the LS system, we tried doing a lot of the things we did with the throttle body which was reduce wiring, keeping it simple. You can see a stock wiring harness that is a stock wiring harness off of an LS car on there. It's got a lot of connections on it. A lot of them are emissions connections, but there are a lot of connections on a stock vehicle. Stock computer is fairly large and bulky. We tried keeping it small. We use the same size power module on the LS system as we do on the throttle body. So it's not anywhere near as difficult to mount, and it doesn't have to be hidden quite as well. The tuning tables and the wiring schematics, don't have to worry about any of those. We got rid of that by actually labeling and pre-wiring most of the sensors. Most of the sensors are terminated right next to where they have to go on the fuel rails as far as the sensors go. We don't have the big wiring harness and the electrical distribution block. We actually, you see an electronic pedal there. We actually will be supporting electronic pedals soon. We're in the final stages of testing on that. Right now we only support mechanical throttle bodies on the LS system, but we will have the electronic pedals out, electronic throttles out soon. You have just a stock GM LS3. We tried selecting the cheaper of all the GM throttle bodies and pedals, so they're easiest to install. Basically the same ones that come in the E-Rod kit would be used on our system to keep the cost down for the customer. That's the entire kit, minus fuel system, but the power module, the handheld, that's all the wiring. The main wiring, there's only one wire that goes between the fuel rails and the power module. Actually two, I'm sorry, the power wire and the CAN bus wire. So that way we can keep all the sensor wiring out of the way. The sensor wiring stays very short and stays right there on the fuel rails itself. We do that by actually integrating the ECUs. There's ECUs on each fuel rail. So the sensors feed information back to those, and they're all driven by that, and the microprocessor there sends the information back to the power module over the two wires, instead of having 8 or 10 sensor wires and all the fuel injector wires having to run back to the firewall. There's only the, you can see it up here, it's one fairly small wire that goes between the two, or appears to be one wire. It's self-tuning. The menus on the handheld are part number based with stock GM part numbers. We have all the stock GM, as far as I know, all the stock GM map sensors for LS motors from 97 to 2012. Map sensors, fuel injectors. You actually just put in the part number. You can look on the injector or the map sensor and put it in, and it'll do the calibration automatically for you, so the customer doesn't have to do any setup on different map sensors, things like that. Injectors, all the fuel flow rates and everything are there for the part numbers. If you have a custom map sensor or custom injector, though, say you want to run a 90 pound per hour injector or something like that, that's just fine as well. You can actually enter custom and just type in the flow rate of the injector, or put the curve of the map sensor in there. It has sequential fuel and spark. It does support boost and nitrous. The fuel rails, boost-wise, you can get right now you can do a 2.5 bar map sensor in there. So if you're running a full 24 pounds of boost, it's 1,600 horsepower in that area. We say the fuel rails support 1,000 without a problem. They're actually -8 internal. So if you do a -10, Ying up a 1,600 is really not a problem at all. It does control variable valve timing. It auto-selects the 24 or 58X reluctor wheel. You don't even have to know which one's in there. You have to have the right sensor in there and the right pigtail plugged in, but as long as you have the right sensor in, you just turn it and it'll auto-detect the crank and the cam sensors. Throttle-by-wire capable. Like I said, that will be coming out very soon. It is being driven around right now every day. We've got a few cars driving around with it doing testing, and it's performing very well, and just have to do the final calibrations on it. Handheld, same as the throttle body. It's operated with a joystick. It's menu-based, preloaded with, again, as far as I know, every LS motor, even the Australian versions and things like that. If you select the motor, it'll automatically select the given fuel injectors that came on that motor. So if you have a stock junkyard motor and you know what it is, if you type that in, it'll automatically fill in the injectors and the map sensor that came on that motor. If you don't want to use that one, then you can change the injectors and map sensor if you're using a different one. And it is preloaded again with the popular fuel injectors, coils, map sensors, things like that. Cams, you can do this, the stock mild or a performance camshaft, again up to about 250 degrees duration. So the map sensor, as long as we're drawing about 8 inches of vacuum. Fuel rail covers, those are actually being finalized right now. Those are just some different custom ones. They will snap right on to go over, just like the stock Corvette ones. They are almost done as far as production. They should be released here in the next few weeks. We're just finishing up packaging and things like that. So they can go on to really customize the look of the motor and blend in with the car. All of them come blank or red. Those are just different ideas of what you can do to them. Again, different ideas of what to do. Those we just cut holes in them and made molds to go around the coils. Not even molds, but just little plastic holders to show off the coils on our cars. That was a SEMA engine from a few years ago. And there's one installed on a car. It's a 57 Chevy. So no covers on there yet, but that's what the engine bay looks like. There's not a lot of wiring going everywhere. It's just the injector wires go straight down from the fuel rail to the fuel injectors. Coolant temp sensor short. The throttle position sensor, everything goes directly to a sensor and is the correct length already. So there's not a lot of extra wiring hanging around. And again, going back to the power module, there's just the two wires. So